Okay, hello everyone. Thanks for joining today's webinar session for the VMware Virtual SAN Beta Program. I'm Liz Moran from Beta Program Management. Today's agenda includes an introduction and overview. Leading the session today will be Kiran Madnani from Product Management. A couple of notes, all phone lines have been muted for this online meeting, so we strongly encourage you to use the online Q&A window to submit any questions so our team can respond. Also note, the session will be recorded and posted on the vSAN Beta community later this week. So with that, I'll now turn it over to Kiran to start the session. You'll need to press *6 to unmute your phone.
Thank you, Liz. Thanks everybody for joining me today for the Virtual SAN introduction. My name is Kiran Madnani. I am a product manager at VMware in the Cloud Infrastructure Products team, responsible for some of our key software-defined storage initiatives. The agenda for today is pretty short and sweet. I'll first go over the beta overview, and then I will give a little product overview of Virtual SAN itself. Note that over the next few weeks, we have planned additional webinars with a great set of speakers, so make sure you stay tuned for announcements of those webinars themselves. Okay. Let's start with the beta overview. The first and most important thing is that the bits are now available. I know quite a few of you have been waiting for the bits to come online. They have been made available as of this morning. So, for those of you who haven't signed up for the vSAN beta itself, it's relatively simple to sign up. You need to go to vsanbeta.com and fill out a simple form, and then you'll receive an email with instructions on how to log into the vSAN community website in order to get access to the bits, documentation, and other additional material. Once you log into the vSAN community page, this is a quick view of how it looks. You will see that we have posted a number of documents and videos on the community page itself. In addition, there are a number of threads where you can interact with the VMware vSAN product team itself, as well as other beta participants. Okay. How do you get started and download the bits? The bits themselves are available on the community page. Once you download them, a key step is to input the license key itself in vSAN itself. I will share the place where you can input the the license key itself on the next slide. If you do run into an issue, you can submit an SR, which will then be triaged by VMware Global Services. Here's how you can input the license key for vSAN itself. Once you have created your installed ESX and vCenter, you can input the license key under Cluster Settings under the Virtual SAN Licensing tab itself. The license key itself is available on the communities page. In addition to the bits themselves, we are also pleased to announce the Virtual SAN being available as part of a hosted beta. In case you don't have your hardware set up and ready to go to give vSAN a test ride, we have also introduced the hosted beta component itself of vSAN. This will allow you to test out vSAN as it is hosted on our infrastructure. If you do run into an issue with vSAN when you're testing it out as part of the hosted beta, you can click and submit a bug relatively easily. It's called vsub a bug. That's the tab where you can submit it as part of the hosted beta itself. In addition to the bits themselves, we have posted some great collateral and videos as part of vSAN. Of particular note is the POC kit and the design and sizing guide that are posted on the communities page. these documents share a great deal of information of how vSAN works, how it can be sized, and how you can design a vSAN cluster itself. Okay. Now let's turn to the product overview itself. So what is vSAN? vSAN or Virtual SAN is a storage solution that has been developed from the ground up by VMware. It is a scale-out storage solution that is built into the hypervisor. vSAN or Virtual SAN clusters multiple ESX hosts and direct attached storage within these hosts to present a data store called the vSAN data store. This data store is optimized for performance through the use of flash and uses magnetic disks as the persistent store of the data itself. This solution is built using software itself and can be deployed on industry standard components. From a management perspective, vSAN is tightly integrated with vSphere, all of vSphere's management constructs. So it can be managed through the web client or through APIs and CLIs. It's tightly integrated with other compute components of vSphere, including HA, DRS, and vMotion. In addition, in terms of data services, vSAN leverages existing data services in vSphere itself, from thin provisioning to snapshots and clones, vSphere application, and SRM. Drilling into some of the features itself, vSAN, as I mentioned earlier, is scale-out in nature. What that allows for is the ability to dynamically scale capacity and performance on an as-needed basis. One can start with a small cluster with magnetic disks and SSDs, and then add more performance capacity or capacity to store the data itself in the existing cluster in order to increase the data store size of the cluster, data store size itself, or the storage pool itself. In addition, one can add storage component or additional servers with storage in them to scale the size of the cluster itself. One could also add compute components or compute servers into the vSAN cluster. A key point out here is that vSAN provides tremendous amount of flexibility on how one can scale their environment based on the needs on a just-in-time basis. vSAN provides a shared storage semantics. In order to do so, vSAN implements a distributed RAID algorithm to ensure there is no single point of failure, whether it is SSD failure, magnetic disk failure, or a NIC card failure, or a host failure, or even a network partition. vSAN leverages flash as a read cache and a write buffer in front of the magnetic disks that act as a persistent store of the data itself. Another key attribute of vSAN is that it provides VM-centric management. What I mean by that is with vSAN, one can set policies on individual VMs or VMDKs. These policies reflect capacity, performance, and availability attributes of the virtual machines themselves. And vSAN takes this into account while deploying the virtual disks onto the data store itself. What this does is it ensures that one could set SLAs on a per VM or a per VMDK basis on the vSAN data store itself, and vSAN always ensures that those SLAs are in compliance. This is a key attribute of Virtual SAN that allows for deployment of multiple VMs and VMDKs, each with their own SLAs at scale. Let's look at the requirements of Virtual SAN itself. In order to deploy a cluster, one needs at least 3 ESXi hosts with vSphere 5.5. In addition, one could use a vCenter server, whether it's in a physical form factor or the vCenter server appliance, in order to manage vSAN through the web client. Note that on the communities page, everything you need in order to install vSAN has been made available. So there's no additional software you need to go and download from elsewhere. Each of these three hosts requires at least one SSD or one flash device and one magnetic disk. You could have multiple SSDs up to 6 on any given host. In addition, you can have multiple magnetic disks up to 36 on any given host. But however, a key point to note out here is that you need at least one SSD and one magnetic disk on each of the three hosts. As you add more hosts to the cluster, they may or may not have storage. However, the best practice is to have a fairly balanced cluster. In terms of networking itself, vSAN supports both 1 gig as well as a 10 gig NICs for inter-host traffic. The best practice would be to use a 10 gig NIC. In order to configure vSAN, virtual networking needs to be configured to have all hosts on the vSAN network itself. Note that for vSAN, we have created a new VM traffic type called Virtual SAN or vSAN that you can configure, just like you configure management traffic and vMotion traffic and so on and so forth. So to recap some of the requirements, you need a server that's part of the vSphere HCL, although we encourage you to try it out with any hardware that you have in your lab. A 1 or a 10 gig NIC, a SAS or SATA controller or a RAID controller in order to manage the disks. And I'll talk a little more about this in the next slide. In terms of the SSD itself, we will be supporting SAS, SATA, as well as PCIe SSDs. In terms of the magnetic disks themselves, vSAN supports SAS as well as SATA magnetic disks. We have created an HCL for vSAN, which is live with vSphere 5.5 right now. You can go to the VMware's compatibility guide in order to access this HCL. The list currently is relatively small, but we are actively working with a number of vendors in order to expand this list. If you don't see your favorite vendor on the list, take the survey and let us know which vendor we should be working with and what your favorite hardware is, so that we can get it on the HCL as soon as possible. Let's look at some of the hardware considerations themselves. As I mentioned, vSAN supports both 1 gig as well as 10 gig NICs. In addition, we will support both the standard switch as well as the distributed switch. One key requirement is to have a separate VM kernel network for vSAN, which is separate from your vMotion network and your management network. Note that from an HA perspective, vSAN and HA will share the same virtual network. In terms of storage controller itself, vSAN will work with an HBA or a RAID controller. The recommended best practice for optimal performance is to use a RAID controller that supports JBOD or pass-through or HBA mode. This is for two reasons. One, vSAN provides the RAID technology or the data protection in software itself. And number two, vSAN has some secret sauce built in order to provide optimal performance on the underlying hardware when it has direct access to the disks themselves. Which is why the best practice is to use a RAID controller that supports JBOD or pass-through or HBA mode. However, we strongly encourage you to test it out with any RAID controller that you have and let us know what the results are. We will be sharing some guidelines on how to configure the RAID controller itself in short order. In terms of the solid-state disk or flash device itself, we do have an HCL. However, we recommend you to test it with SSDs that you have readily available. We suggest picking the SSDs based on performance and reliability. We have shared some guidelines in the design and sizing guide that is posted online in the communities page. So make sure you check that out. As a best practice or a recommendation or a general rule of thumb, we are recommending that 10% of the total magnetic disk capacity itself should be SSD. However, you can choose a lower ratio or a higher ratio depending on your use case itself. From a perspective of the magnetic disk, as I mentioned earlier, vSAN will work with both SAS as well as SATA magnetic disks. In addition, it will work with both 7.2K RPM as well as 10K RPM drives. The trade-offs there are performance and cost. So if you need higher performance, go with 10K RPM drives, else it can work with, the vSAN will also work with 7.2K high capacity drives. Okay. Now let's turn to the product itself and take a sneak peek at how it works. As I mentioned earlier, vSAN or Virtual SAN is distributed software that is built into the hypervisor itself. It makes use of local disks, local flash, as well as local magnetic disks on the ESX host themselves. The flash acting as a read cache and a write buffer in front of the magnetic disks. What this results in is a converged compute and storage platform. So you have your storage controller software running on the same host that run your compute and your VMs on. What this gives is a tremendous amount of flexibility in how one can deploy their a solution and scale it out on an as-needed basis. In order to turn on vSAN, one can just click on a checkbox, just like one can turn on DRS or HA in order to turn on the functionality of vSAN. Once that is turned on, what happens under the covers is that all the magnetic disks and the SSDs are pooled together in order to form the data store, which we'll see in a second. The key point out here to note is that not every host in the vSAN cluster needs to have the same amount of storage in it. As shown in the picture, the hosts to the left have more magnetic storage, and you also have a host with no storage itself that is part of the vSAN cluster. As I mentioned earlier, all of the capacity of the magnetic disks themselves are pooled together to form the vSAN data store itself. Let's take an example. Let's assume each of the hard drives in this picture has a capacity of 2 terabytes each. We have 12 hard drives in the vSAN cluster itself. So the total capacity published by the vSAN data store would be 24 terabytes. Note that this is the aggregation of all the raw capacity of all the magnetic disks in the vSAN cluster. As you add more disks to the vSAN cluster, the size of the data store grows automatically. So if in this case we've added 4 more disks, let's assume that each of these disks have a capacity of 2 terabytes each. What this will result in is the size of the vSAN cluster expanding by 8 terabytes. So the total capacity of the vSAN data store itself would be 20 terabytes. Now, let's take a look at how flash works in the equation. Flash in each of the hosts a read cache and a write buffer in front of the magnetic disks that act as the persistent store of the data itself. A key point to note out here is that since the flash acts as a read cache and a write buffer, its capacity is not included in the size of the data store itself. So in this case, we have 5 SSDs that are part of the vSAN cluster, but their capacity is not included in the Virtual SAN's published data store capacity. Let's talk a little bit about policies and how they work. With vSAN, what we've done is we've extended the notion of profile-based management or policy-driven management that we introduced in 5.1 to what we call now as VM storage policies. What VM storage policies are is essentially a set of SLAs that are created and applied to individual VMs or individual VMDKs, and these SLAs are then enforced during the VM's life cycle. A policy is essentially a set of rules, as I mentioned earlier, that describes the capacity requirements, the availability requirements, and the performance requirements of that would be applied to a VM or a VMDK. In this example, the capacity requirement specified is reserved 20%. What that does is it ensures that the vSAN data store has 20% of the specified VMDK's sizes associated with the VM reserved for the VM for the VM itself. What this allows for is to ensure that while one can use over-provisioning, a specified amount of capacity is reserved upfront for that VM itself. In terms of availability, what's specified out here is the ability to tolerate N failures. So if the policy says that the VM should be able to tolerate 1 failure, whether it is a disk failure or an SSD failure or a host failure or a network failure, what vSAN will do is under the covers is that it would create 2 copies of the data that would be spread across 2 hosts in the cluster itself. In terms of performance, the policy that is specified here is to reserve X% of flash capacity in the cluster itself for the VM for the VM's use. In vSAN, this capacity is reserved for use exclusively as a read cache. For write buffering purposes, vSAN under the covers implements a way such that every VM and every VMDK has its writes automatically go to the individual go to the underlying SSD itself. So from a performance standpoint, one can specify a percentage of the VMDK to reserve on the vSAN cluster for read cache purposes. Now, in order to deploy vSAN at scale, one can specify multiple storage policies and apply each of these policies to individual VMs or individual VMDKs, either through the web client or programmatically through APIs themselves. What this allows for is the ability to create multiple predefined policy templates that which in turn allow for deployment of vSAN at scale. Let's take an example where one has created a policy and applies it to an individual VM. What happens under the covers is that vSAN takes this policy into account while placing the objects onto the multiple disks across multiple hosts in a vSAN cluster in order to ensure that VM and its associated VMDKs are in compliance against the storage policy itself. Here's a view of what the cluster looks like when the objects are laid out on it. As you can see below, at the bottom right corner of the screen, the VMDK, hard disk 1 of the VMDK has been laid out across multiple disks and multiple hosts within the cluster itself. What this allows for is per VMDK distributed RAID as one of the attributes specified in the policy itself. vSAN allows for physical to virtual as well as virtual to physical topology management from the web client itself. Another key attribute of vSAN is that since it's a distributed system, it allows for cluster-wide accessibility of the VM and its associated data itself. So as I just showed in the picture, if a VM runs hot, let me just scroll back. If a VM is running hot on a certain host in a cluster and DRS decides to vMotion it across to another host in the cluster, the VMDKs associated with that VM when residing on the vSAN data store will continue to be accessible irrespective of where in the cluster that VM is running on. In other words, vSAN truly implements a distributed cluster under the covers to ensure that the VM and its associated VMDKs can be accessible from anywhere within the vSAN cluster itself. Let's take a look at what happens when an individual VMDK runs hot, or say there's some change to a cluster, and the underlying objects need to need to be reconfigured themselves. In this case, the VM has one of its VMDKs running hot. What happens under the covers is that vSAN will automatically rebalance the objects in order to make sure that that particular VMDK is in compliance in accordance to its policy. The key point out here is that all the administrator needs to worry about is compliance of the policies themselves. Under the covers, what vSAN does is that it automatically ensures that those SLAs are in compliance. So what this allows for is the vSAN managing the underlying physical infrastructure and abstracting that from the from the admin itself, who then only is concerned about VMs and their associated SLAs, which are specified in as policies themselves. In addition, with vSAN, we have built a great performance analysis tool known as Observer. What this allows for is for detailed drill down into how vSAN is performing, right from an individual VM down to the physical disk, underlying physical disks where the VM's data actually resides. One can have a great end-to-end view of how the various physical components, as well as the virtual machines running on the vSAN cluster itself, is performing in any given cluster. So I would highly encourage you to once you deploy a vSAN cluster, to launch Observer and to see what's happening in your underlying cluster, and post some feedback on the communities page as to what you guys are seeing on your vSAN cluster itself. Now, let's take a look at how one can tolerate failures on the vSAN cluster itself. So let's take an example where a certain host fails on the vSAN cluster. What happens in this scenario is that VMware HA will automatically restart those VMs on other hosts within the cluster itself. Note that based on the policy, there may be multiple copies of that data residing on different hosts within that cluster itself. What happens in this scenario is that the VM will continue to run and its VMDKs will continue to access their data from the different copies of the data that exist on the different hosts themselves. In the background, if the host does not come back, what will happen is that vSAN will start rebuilding the underlying objects that are associated with the VMDK. And once these are rebuilt, the VM's policies will be back in compliance. So 2 key points to note out here. Number 1, that in the event of a failure, through VMware HA and vSAN, the VM will continue to run and will continue to access its data based on the policies that are specified in the virtual SAN for the particular VMs running on the virtual SAN data store itself. Number 2, vSAN in the background will start rebuilding the objects the data associated with the VMDKs on different hosts in the cluster. Note that because vSAN is a distributed system, all the objects would be rebuilt on different hosts within the cluster in order to bring back the virtual machine back in compliance. This rebuild happens in parallel across all the hosts in the cluster itself, in order to ensure that the amount of time when that a VM and its associated VMDKs is out of compliance is minimum. Let's take a look at some of the initial use cases that we are targeting with vSAN. The first use case is VDI. The reasons why vSAN is a sweet spot for VDI is that it provides a converged compute and storage infrastructure which uses flash technologies as a read cache and a write buffer in conjunction with technologies such as View Storage Accelerator or CBRC to smoothen out the performance requirements, the peak performance requirements of a VDI deployment. What this allows for is to support high VDI density or high VDI consolidation ratios, and to do so on an as-needed basis by adding compute and storage capacity when it's needed. So what that eliminates is the need for huge upfront investments in order to deploy a VDI cluster in your environment. The second key use case is the ability to use vSAN in Tier 2, Tier 3 deployments, test and dev deployments, as well as private cloud deployments. What this allows for is for rapid storage provisioning on an as-needed basis through automation. As I mentioned earlier, with vSAN, we will be supporting APIs as well as CLIs, as well as manageability through the web client itself to allow for rapid scaling of compute and storage in conjunction with each other. Again, through the use of a converged compute and storage infrastructure, what this results in is a minimized data center footprint because you're running compute and storage on the same piece of hardware. The last key use case is leveraging vSAN as the DR target. As I mentioned earlier, vSAN is integrated with vSphere application as well as SRM. So what this does is, again, it helps reduce the data center footprint by allowing the vSAN data store to be used as either a replication target or to be replicated, to replicate a primary vSAN data store onto some other storage on the target itself. So, in other words, all combinations, vSAN as the source, vSAN as a target, or both using vSAN as a source and the target will be are supported with virtual SAN through the interoperation with vSphere application and SRM. We've heard of multiple customers telling us that this would be an ideal solution where vSAN would be deployed in their remote office and branch office with the data being replicated onto the main data center, where either vSAN or shared storage system would be the target itself. So these are the key initial use cases we would be targeting with vSAN. We would be very, very interested in trying to understand what your use cases would be for vSAN. Please, as you think about this, please feel free to share these use cases on the beta community site. So, in summary, vSAN or virtual SAN is a solution that's built into the hypervisor itself, which leverages a local or direct attach magnetic disks and SSDs to provide the semantics of a shared storage data store. vSAN is architected to provide VM-level management. This has been done through a policy-based management framework where one can specify per VM or per VMDK policies that then is taken into account by vSAN as it lays out the data associated with VMs and virtual disks. vSAN is tightly integrated into vSphere and has been built such that it can be managed by the virtualization admin. In a nutshell, vSAN provides radically simple enterprise storage, which provides for a significantly lower total cost of ownership without compromising performance. I'd like to now open it up for questions. Before I do so, a key point, you can connect with us on the community site as well as on Twitter using the handle by following us. The vSAN handle itself is @VMware vSAN. Okay. So I see there are a number of questions that are posted in the chat window. I'll try to answer them one at a time. So the first question is from Tony D'Ancona. Can you use Fusion IO instead of the SSD drive? The answer is yes. We would encourage you to go ahead and give Fusion IO a try. And if you see this as a wide-scale deployment with your customers or in your environment, please let us know. We will try to bring them onto the HCL as soon as possible. The next question is by Daniel Grizzard. Will the vSAN network traffic be given special DSCP COS settings in the packet? I don't quite know the answer to that. That's a level of detail that I don't know. I shall take that back with the product team and get back to you, Daniel. The next question is by Uday. Can we have multiple ESXi server nested option and add virtual space as HDD to vSAN? Uday, I don't quite understand your question, but if the question is related to the ability to have multiple ESXi servers in a nested option to be used with vSAN, the answer is yes, you can do that in your lab deployment. The next question is from Tom Phillips. Is the data redundancy managed at a file VMDK level or at a drive level? Tom, as I mentioned in my presentation, data redundancy, data protection is managed via policies, and this is managed on a per VMDK basis. The next question is from Tony again. HA usually implies that the VM goes down and restarts. Are you saying with vSAN, the VM does not go down? Tony, the answer is that VMware HA will continue to function just the way it does today as it interoperates with vSAN. So in other words, as HA works today, where the VM goes down and it restarts on another host, that functionality will continue when it is used in a vSAN cluster. The key point out here is that just like in a shared storage data store, the VMs, VMDKs have continued access to the underlying data. In a vSAN data store scenario too, the VMs, VMDKs will have continued access to their underlying storage, assuming that the policy is created such that there are multiple copies of the data and that data is accessible. The next question is from Tom Phillips. Has pricing been announced? The quick answer to that is no. Pricing has still not been announced for virtual SAN. Expect that pricing will be announced when vSAN is made generally available. The next question is from Uday. If we create multiple ESX hosts on a nested option, will we be able to create a vSAN infrastructure using the virtual disk available? Uday, as I mentioned earlier, if you do use the nested option, yes, you can create a vSAN in your environment. This would specifically be useful in a lab environment where you want to test out vSAN. The next question is from Jonathan Dietz. How will the vSAN feature be licensed? Jonathan, the vSAN's licensing model has still not been announced. Expect this to be announced closer to or at when vSAN is made generally available. The next question is from Kurt, again around the licensing itself. Kurt, as I mentioned earlier, the licensing, packaging, and pricing of vSAN is not announced at the moment. Expect the announcement at GA. The next question, interestingly, is from Eastman Yi. The question is, when will vSAN be GA'd? Eastman, as Pat Gelsinger announced at VMworld, we expect vSAN to be GA in the first half of 2014, along with vSphere 5.5 U1. The next question is from Nick Burleson. Why no deduplication? Will it be a feature released at a later date? Considering the VMware end-user community has made an effort to push persistent desktops as a standard. Nick, as it stands today, Virtual SAN does not support deduplication. We will be looking into introducing this at a later date. The next question is from Aaron Wells. Will there be a way to pool these policies? Aaron, yes, absolutely. You can pool multiple attributes or multiple capacity, performance, and availability attributes within a single policy. The next question is from Daniel Grizzard. I see that vSAN beta has a limit of December 31st, 2013. Will the product be generally available right after this point, or what is the expected release date? Daniel, the beta limit of December 31st has been removed as we speak. The license expiration has been extended. As I mentioned earlier, the vSAN is expected to be generally available in the first half of 2014. So stay tuned for when we for the general availability of vSAN itself. The next question is from Anthony Elizondo. Can vSAN work with auto deploy and with stateless hosts? Anthony, the answer to that is vSAN will interoperate with auto deploy. However, vSAN state information is not stored in auto deploy itself. By definition, vSAN is stateful in nature. In other words, it requires some storage on the host within participating in a vSAN cluster. With vSAN, what we expect is that the boot image of ESXi would be stored in on a local device, whether it is a USB stick, an SD card, flash on motherboard, or a persistent disk or SSD within the host itself. We will have it seamlessly interoperate with auto deploy and stateless in a future release. The next question is from Sarun. Do you have any limit in network latency if I deploy vSAN over 2 sites? Sarun, we don't have a known limit in terms of the network latency itself. This is something that we are actively investigating, so stay tuned for updates on this. The next question is from Aaron. Can we pool multiple VMDKs with the same protection needs into a policy? Aaron, yes, absolutely. A policy that you create can be applied to multiple VMs and to multiple VMDKs at the same point. The key point out here is that a policy is a template that can allow you for deployment at scale. So you can create a single policy and apply it to multiple VMs within the same cluster. In addition, if you decide not to create a policy under the covers, vSAN has a default policy that is applied to to the VMs running on the vSAN data store itself. The next question is from Tom Phillips. The question is, when the beta key has hit its time limit, what will happen to the VMs in the test environment? Tom, once the vSAN beta, the key hits it gets expired, your VMs will continue to run on your vSAN cluster. The enforcement is a soft enforcement rather than a hard one. Other questions? I think I've answered most of the questions in the chat window. We have a few minutes more, so are there any additional questions on vSAN itself? Okay. Question from Pavel. Where does vSAN store configuration data? Great question, Pavel. vSAN it stores the configuration data within within each ESXi host itself. So 2 key points out here. One is vSAN does not rely on vCenter for storing any of its configuration data. In other words, if vCenter itself were to go away or were to crash for any reason, the VMs running on the vSAN data store would continue to run. The other key point is that this configuration data is distributed across the vSAN cluster. So there is no metadata server of any sort that may result in any sort of bottleneck. Next question is from Bob Torrey. Can you state again if the SSD capacity is part of the overall capacity of the data store or not? Bob, the SSD capacity is not included in the published capacity of the vSAN data store itself. The SSD is used as a cache, a read-write cache, or a read cache and a write buffer, and hence the capacity itself is not included in the overall capacity of the data store. Other questions? Okay. Another question from Pavel. Will vSAN be able to rebalance magnetic disk usage without vCenter? What about restore of VM files in the event of the failure when vCenter is unavailable? Pavel, the answer is yes. If vCenter is, since all the configuration data is stored within the vSAN data store itself, vSAN does not require vCenter for any of its operations. The one place where policies are also stored, one exception to that is the fact that policies will be stored in vCenter in addition to being part of the vSAN data store itself. So what that results in is that if vCenter were to crash, those policies that are stored as part of the that are stored in vCenter would be unavailable. However, vSAN also stores these policies, so we'll be able to maintain compliance against these policies within the vSAN cluster. The VM files themselves are also stored within the vSAN cluster itself. So if vCenter is unavailable, these VMs would continue to run and their files would continue to be available. Other questions? Okay, folks, if there are no other questions, I would like to thank you for your time today to attend the webinar. Again, the bits are live. We are highly excited about it. We look forward to you testing vSAN out, look forward to interacting with you as part of the communities as well as other forums. And give vSAN a try and let us know what you think about it. We would really appreciate your feedback. Thanks again for your time. We at VMware really appreciate it.
Okay, this is Liz. So this concludes today's webinar session. Thanks again for joining. We appreciate it. And as Kieran mentioned, we do encourage you to test vSAN beta. And if you have any support requests, you can submit a request via the community. And we also encourage you to participate on the beta discussion forum. So with that, I will close the WebEx.